Hi everyone, today we are having the podcast on the Africa We Want, and we are having myself, Christine, and Becky, and what we are speaking about today is the 3D printing concept, and it's quite interesting discussion. I hope that you will enjoy and post any questions that you have later when you listen to it. But for now, I'll just give Becky to introduce herself and to introduce the topic on 3D printing. Yes, Becky, welcome.
Thanks, Christine. Hi, everybody. My name is Becky. Happy to be back on this podcast and to discuss a very interesting topic. So 3D printing is a technological concept, and I'm in tech, so I'm in the zone. This is going to be a lot of fun for me. So 3D printing, let's start with some fun facts. Earlier this month, I don't think it's 2 weeks yet, the world's first rib-eye steak was printed. Yeah, a piece of edible steak was printed from a printer. And it was created by a company called Aleph Farms in collaboration with the Faculty of Biomedical Engineering at Technion Israel Institute of Technology. So we're not talking about a genetically modified food here. We're talking about using cow cells, like natural, real cow cells, fed into a printer, and then the technology and the process allows for these cells to interact and develop into tissues with the output is real muscles and fat, just like a regular steak. So the only difference with that process is that it costs only a fraction of what it would have cost to raise a cow and slaughter to produce an equivalent amount of steak. And another interesting development is that a few years from now, because the cost of 3D printers is really going down to the extent that in a few years, probably individuals will be able to afford buying them. So you can think about having an application on your phone that will allow you to scan your foot, and then you can go ahead and design on your computer the shoe you want, the design, the colors, and then you can send that design to your printer in your house, and then the shoe drops out ready to wear. No stitching and gluing needed, just ready to go. So I wanted to share these fun facts so that as we dive into this topic, you can probably already see the wide application of this technology. So let's circle back a little bit. So 3D printing, the other terminology, and I might use them interchangeably, is additive manufacturing. So 3D printing, additive manufacturing means exactly the same thing. So let's circle back a little bit. So 3D printing is not a standalone technology per se. It's in the broader picture, it fits within what is now popularly known as the fourth industrial revolution or industry 4.0. So they have fourth means we've had three prior to this. So the first one was all about water and steam power generation, which allowed for processes to be mechanized for the first time. And then the second industrial revolution, electricity was generated, and so that enabled powering of assembly lines, and we started seeing mass production of items. The third industrial revolution, which is some countries are still going through while others have already moved to the fourth, is the use of computers and automation. So that we're very familiar with. The fourth industrial revolution, the key marker is smart manufacturing. And what this means is there are several key technologies. It's not just 3D printing, but the main ones are three. It's AI, artificial intelligence, which means giving machines a certain level of autonomy, some level of intuition, if you will, for them to make decisions and carry out mundane, repetitive jobs without human intervention. The second key technology to the Industry 4.0 is Internet of Things, or IoT, which is allowing systems to communicate with each other and with humans in real time. And the third key technology is obviously what we're talking about today, which is 3D printing. There are other technologies powering Industry 4.0. We have big data and cloud technology and others, but the key ones is AI, IoT, and 3D printing. So what is 3D printing? It's essentially a tool for rapid prototyping. So it's not something that is new. It's not entirely new. It's been around since the 80s. But as with all technologies, it takes a few years, sometimes decades, for a certain technology to become commercially viable at large scale, because often technologies are very expensive at inception, and it takes several cycles of innovation and acceptance for them to become both feasible and affordable. And an example with 3D printers is that the very early versions, they were very slow. So in the first place, even if they were an exciting innovation, it wasn't feasible for commercial adoption, because if it takes you a longer time to print something using a 3D printer than it would have taken you to put it through an assembly line, then there was no point shifting. And the second thing was that they had not achieved precision when dealing with complex designs. So I guess we all probably have made an order and received something that we were not excited about. And so, especially when you're talking about parts, automobile or aviation parts, the stakes are too high. You don't want errors on the output. And there are other concerns like bulkiness. The size of the printers were very large. And of course, we know like how far we've come with something like computers and mobile phones. We had very large phones at the beginning, and now we have smartphones that have way more computing power than the larger versions that we had. So that is usually what happens. Concerns are progressively addressed. And so at this point, we have 3D printers having reached what is called maturity phase, and they're now at a point where they can be adopted massively in manufacturing. Yeah, so I think as a way of introduction, 3D printing is essentially a means to do rapid prototyping, design things, and then send them through a printer. And a printer is just as we know it. It's just that the 3D printers have capabilities to generate way more outputs than we're currently used. Because when we think printing right now, we usually think just the thin paper printer. But yeah, you can have printers that can have the capabilities to output even big things like airplane parts complete without needing assembly, just like wheels or wings or whatever size. So the printers are usually customized depending on what is needed.
Okay, that's very, very interesting. And especially when you even speak about food, like the meat that you spoke about, it's quite interesting. I mean, where it's going. And I think the question that I would ask then, if you could like break it down a bit more, like in the sense of like giving an example. Let's say, for instance, one of the ways that 3D printing has been used is in building houses. So how would that look like, especially when try put it in the context of someone so that they understand like what fits into what, like the ink, what's the output that you expect, like just give that context. But then also the thing I also would like to ask especially is how big is the use of 3D printers currently? Like, who owns them? Is it like something that's very domestic in some countries so that more people are increasingly owning them? And then how about the software? Like the software that's designed to use in the 3D printing. Is it like an app that you download, or is it like that software that's patented to someone? Or how exactly does the software side work? If you know about that. So if you could maybe speak about those, then that would be nice.
Cool. Yeah. So let me start with the first one. So I think the reason this 3D printing sounds outrageous is because when we hear the word printer, the mind just goes to the paper printer, which is just a very limited thing. So let's broaden our imagination and think about ink as any input. So in a normal paper printer, you put ink and you put paper, and then the output is a written paper with whatever you have fed. So let me circle back. for you to print a document, you need the soft copy of the document somewhere, and then you need ink, and then you need a blank paper. So say if you're printing a shoe, for example, I gave an example of a shoe. So your inputs will be your soft copy of the shoe, which means it had been designed in advance with all the specifics of what color, what size, what fabric you want at the front, which one you want inside. And then you will have, so that would be your soft copy document, quote unquote. And then your ink now would be the materials, all the different materials. So for each particular use case, if you're doing shoe printing, that it means your shoe printer has different places for you to insert the different materials that are needed for that particular product that you're making. So that when everything has been put in place, just as you do with a printer, before printing, you check that the ink has the cartridge has enough ink, and then you make sure that your printer is connected to the computer, and then make sure there is blank paper. And then you hit print. So it's essentially the same thing, but obviously if you're printing something bigger now, the time might not be the exact time that you drop a printed paper. But essentially, it's essentially the same process of input and output. It's just that in this case now the printer will have places for you to insert the relevant materials. Yeah, so I hope that clarifies that. How big is 3D printing? So at this point, I think the largest use cases is automobile and aviation industry. It's been largely adopted by big manufacturers, and I think the largest of them being GE, General Electric. So it's currently really taken off. And aviation is a big industry, so when you have it going on there, you can only expect that it's going to take off in a big way in other industries. And I think Stratasys is one of the organizations that deal a lot with I think mostly the hardware part, like designing the 3D printers, and I think also the software part. So I think with the software, obviously there would be a kind of application that you use to generate that design. So I'll go back to our example of a normal printer. For me to be able to print a document, I need to have typed it using something so that then I can send what I typed to the printer. So keep that image in mind as you will have a software. When I'm typing a document, I need either OpenOffice or Microsoft Word or something. So there will be a software where you design your product, and then there is printing capabilities from within that software. Just the same way as when I type a Word document, I can print send right from there, or I can save it and then send to printer from a flash disk or something of the sort. So there must be a software that has the designing and prototyping capabilities, and then you can export what you have designed. So yes, it takes a specific software to do that. And I think then that differs depending on what you are building, because now the use cases are very, very varied. So what you're going to need to design, say, a car parts, and for you to design bricks or a 3D house design is probably going to be different. So yeah, but as with all the other software, there is a whole variety and room for innovation. And I think the great thing, and I think I will just go straight to that point, is on how 3D printing is changing businesses. That's one of the key things, that because you're dealing with virtual designs, you have the capability to, it's very flexible because your design is somewhere virtually. You can play around with it. You can add things and remove things and do very quick iteration before you commit your products to a production line for mass production. So it allows you that room to play around with the design until you perfect it. And so it means you can design a whole house, or you can just you can design a part. It doesn't matter what you're designing. The software can, take any design. I think what will differ later is when you need to print, then it means you might need different printers for different purposes. But even the printers themselves, most of them are very highly flexible in such a way that one printer can quickly move. Like one printer might be able to print parts for a car, a bicycle, and lawnmower. Same printer for different parts. So there is a lot of flexibility, both at the hardware level, the printer can do several things, but also at the software level, where you have the freedom to do very quick iterations on the design. So in terms of the software and hardware, it's revolutionary on both ends.
Okay, Becky, that's very interesting, and I think you've answered it well. And I think the thing then to also maybe go to, especially because this is going to literally change manufacturing, it's going to change, almost cut middlemen. You'll be able to manufacture for yourself, if I may put it that way. You'll be able to create a product for yourself and cut the entire middleman. So for instance, where someone would need to take raw materials from this place, then put them in a ship, then take them to an assembly plant, and the assembly plant is segmented so that a part of it is done in one place, then the other place, then assembling is done. All that just gets cut away by just adopting 3D printing. So when like this becomes like a common everyday usage, it's going to disrupt a lot of businesses. One, because they will either have to like take on the technology, but then also it's going to like greatly impact the global value chains and how, whether it's services or goods, and how entirely that is done, it's going to impact it a lot. So coming to Africa, what do you think are like the opportunities that Africa should be like looking out for in this area? And if you ask me, I think Africa was so far behind. It's almost shocking to realize how fast things are moving and how far behind we are, because in reality I don't think we are anywhere close to like this. But you can share your perspective, especially on the skill levels, on like because I would think there's a lot of like tech skills that you need, and then also the infrastructure, the technology infrastructure that will be needed to do some of these things. But speak about like the opportunities that someone in Africa could look out for.
Good question. And to agree with you, 3D printing is going to totally disrupt manufacturing as we know it, and create new opportunities and take away, some opportunities for some. Especially, we know that there is a whole lot of over-reliance on exports, and a lot of this is going to change. So so one of the examples that has been given by one of the experts on opportunities for developing countries is literally the example of M-Pesa, showing how M-Pesa allowed Kenyans and a lot of other Africans to leapfrog from never having owned a bank account to being financially included. So we're talking about disruption of that kind, where people who previously were not doing any manufacturing at all, who had no access to manufacturing capacity, will be able to do manufacturing either for, in small scale or in large scale. And so, we are behind the rest of the world in terms of technology. But in this case, I consider that to be an advantage. But it all depends on whether African businesses will seize the opportunity or not. And this is why I think that it's an advantage. So we currently don't have a lot of manufacturing going on in the continent, which means that African businesses have not heavily invested in expensive production lines. Because if you had already heavily invested in a traditional assembly line, it takes a lot it's capital intensive. So you can't just wake up one day and say, okay, let's just get 3D printers and change our whole process. So as value addition initiatives increase in the continent, it means that those companies that are setting up new manufacturing operations can now dive straight into 3D printing and all the other smart manufacturing technologies I talked about, IoT and AI. So we actually have an advantage of being among the early adopters because we don't have baggage. We are only starting now, and we have talked about it, in this podcast before about, the need for there to be more value adding processes within African products. So it's actually an advantage the way I see it. And let's just contrast traditional manufacturing to additive manufacturing for us to be able to see the benefits more clearly and why it would even make sense for small-scale entrepreneurs to think very, very carefully about adopting 3D printing. So a traditional manufacturer gets higher profits through economies of scale. And for that, you need a lot of initial capital to put together an assembly line and your whole supply chain for all the different materials that you need. So traditionally, it's cheaper when you make 1,000 units of something. But if you try to produce like 10 units of that same thing using the very same assembly line, it's outrageously expensive. But with 3D printing, the cost per unit will remain low, whether you make 10 units or 10,000 or 1 million units. So essentially what this means is that you don't need to be a multi-billion company to do manufacturing because setting up a 3D printing line is less capital intensive. And one of the things that we know is a hindrance for entrepreneurship in Africa is access to capital. So you probably have this idea that needs an assembly line, but there is so much red tape in access to finance. So because the 3D printers are getting more and more affordable, and in general compared to a normal assembly line, they are like a fraction of the cost. So it means that even small businesses will be able to afford and they won't, without having to go through the kind of, suffering it is currently to access capital to set up your business. And the other point, and we talked about it, I think last week, is, the cost of electricity. Because, having an assembly line, and that is one of the reasons why it has not been possible for both, local entrepreneurs and even foreign investors to set up manufacturing activity in Africa because of the cost of electricity and also the intermittency. So the 3D printers are very energy efficient and also they require less electricity. So this means that they can even be powered with small generators. So essentially I can be in the village out of the national power grid and I can still set up my 3D printing business. So it is a game changer, whichever way you look at it. And that's why I think this is not one of those, technologies that we can say, oh, let's chill and see how it's panning out in the West before we try it out. I think this is one of those that we can't afford to be laggards on. We have to jump on the bandwagon while it's still early because this is yet another opportunity I think not even another, I would say this is the opportunity for the African continent to leapfrog all the steps on the third industrial revolution that we missed. And we can catch up with global, industrial levels. And, for people thinking about, yes, you said it's affordable and everything, but I don't know anything about it. I think the two, or a starting point would be to follow very closely what, General Electric and Stratasys are doing in this area. They're working specifically in developing countries to create awareness and train entrepreneurs to build domestic capacity for them to understand what's 3D printing and where do we get these printers and how do we operate them. So GE opened a couple of years ago, opened incubation centers in Algeria and Nigeria to train African entrepreneurs on how to work with 3D technology so that they can spawn off and go start their own 3D printing ventures. So there is initiative even from some of the leading companies in this area in the world in trying to build capacity for the African continent.
Wow, okay. Becky, that's very good to hear. I mean, you share like such good information, and when you speak about it, it actually looks and sounds possible to actually do for even with Africa being not as technologically advanced as the West or even the East. But then I think what I would possibly we can do this in the next discussion, which we could then look what's the investment that someone needs to make to be able to participate in 3D printing. Like, because now the investment, as you speak about it, the investment is not like in the brick and mortar economy where you need a warehouse to store the goods, where you need electricity connected to you and you need chains, of like a physical location. But then the question is, what's the investment that a person needs to make other than buying the printer itself? What's the real investment that someone needs to make sure this takes off? I think you can either briefly mention that, but then we pick it up in a bit more detail, possibly in the next podcast, because I think we have run out of time.
Yeah, so I think just to answer that briefly is, I think the reason it sounds like too simple, because you answered the question while asking it. Is it really just about getting the printer and the materials? Really, it is. And that's why it is mind-blowing and transformational, because so what we're saying is one of the greatest advantages is that you will not need as a business to keep inventory, like have a whole warehouse full of stuff. Because the only reason that keeping inventory has been a thing is because you need to mass produce things at scale for it to be feasible. But now the fact that you don't need to do that, you don't need economies of scale as an advantage. You only need to keep a virtual inventory. For example, going back to my shoe example, if I'm a shoemaker, I can just keep my shoe design as a virtual inventory, and then someone selects. Everything is going to be virtual. And so let's assume in this case that I go to a website, select the shoe that I want. You, as the shoe manufacturer, don't need to have it somewhere on the shelf. You can print it when I ask for it and deliver. So yeah, it sounds too simplistic, but really it's going to be simple. It's going to be a lot simple, both in terms of the intensity, like you don't need too much space, you don't need a whole warehouse and a very sophisticated assembly line. It's going to be simpler in terms of size and other requirement, and also in terms of supply chain. It sounds simplistic because it's really going to be simpler compared to manufacturing as we know it.
Interesting. And what are the skills? Like, are there any specific skills that you'll say these are the skills that someone would need to look out for?
Yeah, there is going to be specific 3D printing skills, which it's going to be very computer intensive. So there is going to be need for specific, like designing and prototyping. So people will need to be, as a small business person, you probably might be skilled at designing on paper or what you do. So you will need either to upskill to know how to work with the software to translate the things that you design from manual, or if you have like physical molds, because sometimes people keep a physical prototype, for you to know how to translate your physical prototype into the software. But as I've mentioned, there is already courses that have been rolled out to help entrepreneurs in this transition to transition from the normal physical manual design to designing and prototyping using the available software for 3D printing. So there is specific skill sets that are required, and there are already courses that have been rolled out and programs for entrepreneurs to quickly upskill and catch up.
Okay. Becky, thanks a lot. This is such useful information. And for those listening to this, thank you very much for listening in. You can leave your comments and let us know what you think, and also ask any questions that you may have. We'll try and answer them in our next podcast. Becky, thanks very much for doing this today.
Thank you.